talk about the thermodynamics. Okay, okay, all right. You go rub your hands together for 15 seconds. Ready, go. 1, 2. Are you doing it? Are you doing it? You look like an idiot. Stop it. What are you doing? There's a video. Your hands warm? Huh? Well, it's probably because you didn't rub them together. If you rub your hands together, it gets warm. You create heat with friction. So thermodynamics is it's concerned with the heat and temperature and the relationship to energy and work. And we've been talking about energy and work, and we're going to talk about heat now. Like heat and temperature, the transfer of thermal energy. Usually we're going to be talking about a system, so we will be transferring thermal energy from a system to its surroundings, or from the surroundings to a system. Well, yes. It'll be different for each case that we have. Alright, so thermal energy is the internal energy of an object due to the particles. I'm moving my hands around, but you can't see it. The particles inside the object vibrating and like hitting each other and making heat. It's the kinetic energy inside the object, or whatever we're talking about. Temperature, on the other hand, is the average kinetic energy for an object. So if you have like a really large object, it may have the same temperature as a really small object, but if they're the same temperature, the very large object has more thermal energy just because it has more particles. If they're the same density, has more particles in there moving around and bouncing around. Oh, okay. There's a couple of different ways that we measure, or a couple of different scales that we measure temperature. You may have heard of these in Celsius. We've all heard of Celsius, where 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water. Celsius is nice because that's like 0 is a good starting point. 100 is nice, flat, like it's boiling point of water. That's good. Fahrenheit is what we normally use for temperature outside. When you say it's like, oh, it's 80 degrees outside, you're thinking of Fahrenheit. And it has a freezing point of 32 degrees Fahrenheit and 212 for the boiling point for water. We're just using water. And then there's kelvins. Kelvins are a scale that accounts for absolute zero, when there's absolutely no particle motion, no molecules moving inside any object. That would be 0 degrees Kelvin. But can never. I don't think we can measure 0 degrees. If you tried to measure, like to get 0 degrees Kelvin, you'd have to disturb the environment. You'd have to cause some kind of vibration. Then it wouldn't be 0 degrees anymore. So like you can't really measure it, right? They'd have to do something. I don't know. Maybe I don't know. Let's read what these words say. Matter is made up of molecules in motion. Okay, that's fine. An increase in temperature increases motion of the particles moving around. The molecules inside. The temperature rises. Decrease in temperature decreases the motion. Absolute zero occurs when all kinetic energy is removed from an object. And that would be 0 degrees Kelvin, which is negative 273 degrees Celsius. All of this you should memorize. No, no, you don't have to memorize that. Moving on. So when we're talking about the thermodynamics and thermal energy, we have to talk about thermodynamic equilibrium. It's when there's no more transfer of thermal energy between objects. Thermal equilibrium is obtained when the objects reach the same temperature. So if one object is colder than the other one, then there's going to be some transfer of thermal energy. But if they're the same temperature, then that's called thermal equilibrium. The Zeroth Law of thermodynamics. I feel like they made a couple laws, and they're like, wait a minute, let's add one more. This should be like the first one, and then they named it the Zeroth Law. I don't know, maybe. I don't know. I just made that up. So it says, if two systems are separately found to be in thermal equilibrium with a third system, the first two systems are in thermal equilibrium with each other. That's just saying, if you measure the temperature of something, and then you measure the temperature of something else, and they have the same temperature, then they have the same temperature. That's all. That's all that it's saying. Just silly. It's just, let's make sure that we can measure temperatures. Let's have a law. It's silly to me, but hopefully it's silly to you. It makes sense to you. Hopefully, I don't know. I'm not in your brain. Now the transfer of thermal energy, which you can think of as heat, it can happen in a couple different ways. First, convection. I always think of a convection oven. The convection, it just means the heat is transferred through a fluid, and you can think of the air in like an oven as a fluid, where the hot air rises, or the hot fluid is less dense. The particles are bouncing around, so there's more. It's less dense, and it rises, and the cooler air falls, and then gets heated up or whatever. So a convection. I guess I'll write that. So convection is like movement through fluid. It doesn't have to be air. It could be water. But the idea is that when something's heated up, it has more thermal energy and it expands because the particles are bouncing off each other more violently. So it expands. So it's less dense. And then the more dense, the cooler stuff is more dense because the particles aren't moving around as much. On top falls towards the bottom, and then there's a heat transfer because the warm stuff is being pushed up, and it's like mixing itself, so that it results in heat transfer. Okay, conduction. Let's move on to conduction. So the way I think of conduction for thermal energy transfer is through touching. With convection, the fluid is like moving all around. Through conduction, there's no fluid involved. It's just one material touching another material. The materials aren't like moving around at all. Just the materials are touching and transferring the heat. The last type of heat transfer or thermal energy transfer is through radiation. And radiation is the transfer of energy, thermal energy, as electromagnetic waves. So, like in a microwave, that's what's happening. You're transferring thermal energy into whatever food. You're nuking your food. That's why they say nuking, because it's like radiation. Same with the sun. The sun transfers heat to Earth through radiation. These little notes at the bottom saying 100% efficiency is unattainable, meaning when you transfer some energy, you're always losing some heat energy or thermal energy to the environment. And all processes are irreversible unless you heat it the other way. But that's not the same thing. I'm going to continue in the next video.